Okay, continuing with our properties of logarithms as we go into this next section, we're going to learn about the product, the quotient, and the power property. And one thing that we've talked about in class is that a logarithm is, in essence, nothing more than an exponent. And we can look at our exponent rules and see how they're connected to that when we talk about properties of logarithms. So here we talk about the product property. And the product property is when we have a log of base b of m times n, because those two variables are being multiplied together, that would be equal to the log of base b of m plus the log of base b of n. Now think about it, exponents, when we are multiplying like bases, we end up adding the exponents. So there you go, that's what we're doing here, is we're adding the exponents. So we have, again, the log of base b of m times n is equal to, separating it into, simplifying it, we would have the log of base b of m plus the log of base b of n. Now, when we come over here for our quotient property, now quotient is division, so we have the log of base b of m divided by n. And we know that when we are dividing like bases and exponents, we end up doing subtraction. So we end up seeing the same thing here for our logarithm properties. So again, the log of base b of m divided by n is going to equal the log of base b of m minus the log of base b of n. And then our power properties. We have the log of base b of m raised to the n power is going to be the same thing as n multiplied times the log of base b of m. And that's my power rule. And again, when we are raising a power to a power, we're raising a value to a power, then we multiply. So we're seeing some of our exponent properties displayed here as we go. So a quick example. Okay, so a quick example is when we take the log base 4 of 5x. Well, we know, again, that's multiplication. So if we were to separate that, expand that expression out, it would become the log of base 4 of 5 plus the log of base 4 of x. So we just expanded out our expression. And then if we were to have the log of base 4 of 5 divided by x, that would be the same thing as the log of base 4 of 5 minus the log base 4 of x, because there again lies in the division is going to end up being subtraction. And let's see our power rule. The log of base 4 of 5 to the x power is going to end up being x times the log of base 4 of 5. So there you have it. Those are some quick examples of our properties of logarithms, and now we'll go on to the next slide. So looking at our notes, we have, okay, as we go from expanding our logarithms to bringing them back as a single expression, and that's what they're asking us to do here, is a single log or single expression. So we have the addition sign, and we should remember that the addition sign is when I have two logs of the same base being added together. That is the same thing as multiplication. So I should be able to bring these back together as log of base 4 of 5x times 3x. Now we can simplify that more to the log of base 4 of 15x squared. And that would be a single expression. And as we continue here with this next expression, going from left to right, let's go ahead and work with this term first, and we should see that we are going to end up having the power rule. So we can reverse the power rule. So that becomes the log of base 4 of 6 squared minus the log of base 4 of 9. And then now that will become the log of base 4, because remember, this subtraction is going to equate to division or a fraction. That should be the log of base 4 of 6 squared over 9, which is going to be the log of base 4 of 36 over 9, which is going to be the log of base 4 of 4. And remember that a log is asking us what the exponent is. So what exponent would I have to take base of 4 to get to 4? Well, that's sort of an identity here. A log of base 4 to 4, or the log of the same base as the number, is going to be equal to 1. Remember that it is an exponent, so the log of base 4 of 4 is going to be 1. I'm raising the base of 4 to what power to get to 4? To the 1 power. So there you have it. That one simplifies down to 1. Now, as we go to this next example, when we expand, we want to create prime values. When I talk about prime values, 250, that's not a prime value. When I'm talking about 37, well, 37 is a prime number. So there's nothing more I can break 37 down into, but as I'm expanding this out, I know that, to think about it, I know that 250 is the same thing as 2 times 150. No, it is the same thing as 2 times 125, sorry. And then I know that 2 is prime, and then what can I do for 5? And looking that I'm dealing with this power of 3, I know that 125 is actually 5 cubed, so that's going to come out to help me here in a minute. But as we go through this, my apologies. As we go through this, I know then, if I start here, I know the log of base 3 of 2 plus the log of base 3 of 125 minus the log of base 3 of 37. Now, let's see here. So I know then that it looks like this is going to be a prime. This is a prime. So what can I do to this thing right here? Well, using some properties, I know that 25 is going to be the same thing as 5 cubed. So what I can do is I have the log of base 3 of 2 plus the log of base 3 of 5 to the third minus the log of base 3 of 37. And so I'm getting close. There is one more thing that I do need to do, and I need to take this and use the power rule. And therefore, I'm going to end up with the log of base 2 plus the log, 3 times the log of base 3 of 5 minus the log of base 3 of 37. And that is now an expanded form of that original logarithm. And continuing on here with this next example, let's see. I do know that I have some junk here, and looks like I've already done the first step, right? I had the power rule. I've already provided you the first step, and I've created the log of base 3 of 9 plus the log of base 3 of 5 of x to the 5th. Okay, so then if we continue on, that is the log of base 3 of 3 squared plus the log of base 3 of x to the 5th. Both of these now have a power rule. So I have the power rule right here. I have the power rule right here. So I can rewrite this as 2 log of base 3 to 3 plus the 5 log of base 3 of x. And remember, this is an identity right here that we talked about. Log of base 3 to 3 is going to be equivalent to 1. You can check it in your calculator if you need to. Oops. Base 3 of x, and then therefore this is going to simplify just to 2 plus the 5 log of base 3 of x. And there you go. There's your expanded form of that logarithm. So again, expanding and simplifying and compressing, creating single terms and expressions is just using your properties and finding some of those prime values. Doing our change of base formula here, here it is. The log of some base of m equals this, okay? This is when we don't have, we're going to learn there's some standard logs in math, and if you don't see, if I have the log of m, Well, that is understood that is log of base 1, or I'm sorry, log of base 10. So there's sometimes that we're going to be able to change our formula, change our logarithm to make problems a little bit easier for us. So this, simply using the change of base, again, we have the log, and b of m equals, well, in this example, b equals 8 and m equals 32, so we can just substitute in here. And I could have the log now of base c. C is any value we pick. So I'm just going to use the log of base 10. And remember, it's base 10 even if you don't see it. It's the understood. So the log of base 10 of my m value, which is 32 over the log of 8. And there we go. We are simplified here using our change of base formula. And you're done for simplification here. And then for our next one, using this same formula, b is equal to 4 and m is equal to 18. And we have the log of base, I'm going to use 10 again, and just by it not being there is 10. The log of 18 divided by the log of 4. And there you have those simplified using our change of base formula. A little bit easier than you might have thought it would be. Now we can, of course, put those into the calculator. And 1 second here. Are we done? If you were to put those in the calculator, I do believe that this would be 1.667 or 5/3. And this one would be approximately 2.085.